Hello everyone, today we are going to learn about trigonometric ratios of some complementary angles. Well, as we all know that two angles are said to be complementary if their sum is equal to 90 degree. In that case, we call the angles are complement of each other. Consider a right triangle, right angled at B, then the measure of angle B is equal to 90 degree. In that case, AC is the hypotenuse of this triangle. Now, by the angle sum property of triangle, angle A plus angle C will be equal to 90 degree, or we can say angle C is equal to 90 degree minus angle A. Now, if we take this angle A as theta, then by the definition of complementary, angle C will be equal to 90 degree minus theta. Now, if we calculate trigonometric ratios for this acute angle theta, which gives us the relationship between this acute angle and the lengths of the sides of this right triangle. So, the first trigonometric ratio is sine of angle theta, abbreviated as sine theta. But we know that for this theta, AB is the side adjacent or base and BC is the side opposite or perpendicular and AC is the hypotenuse of this triangle. So, sine of theta is the ratio of side opposite and the hypotenuse. So, sine of theta will be equal to BC divided by AC. Now, cosine of angle theta, that is abbreviated as cos theta, is equal to the ratio of the side adjacent and the hypotenuse. So, cos theta will be equal to AB by AC. Similarly, the tan of theta, that is equal to side opposite, the ratio of side opposite to the side adjacent, that will be equal to BC divided by AB. Similarly, we can calculate other trigonometric ratios which are actually the reciprocals of these trigonometric ratios. Then we can calculate cosec of theta, that is will be equal to AB by BC. Similarly, sec of theta, that will be equal to AC by AB, and then cotangent of theta, that will be equal to AB divided by BC. Now, if we calculate the trigonometric ratio of the complement of this theta, that is actually the 90 minus theta. So, if we reference to 90 minus theta, for this 90 minus theta, BC is the side adjacent or the base and AB is the side opposite or the perpendicular. So, we will calculate trigonometric ratios for this 90 minus theta, which is actually a complement of this theta. So, the first trigonometric ratio is sine of 90 minus theta, that is the ratio of side opposite to the hypotenuse. So, that will be equal to AB by AC. Similarly, cos of 90 minus theta, that will be equal to BC by AC. Then tangent of 90 minus theta, that will be equal to AB by BC. Then cosec of 90 minus theta, that will be equal to the AC divided by AB. Then it is the sec of 90 minus theta, that will be equal to AC divided by BC. Then finally, cot of 90 minus theta, that will be equal to BC divided by AB. Now, if we compare these two sets of trigonometric ratios, that is for theta and 90 minus theta, from this we can see that sine theta is equal to BC by AC. Lekin from here, cos of 90 minus theta is also equal to BC by AC. So, we can calculate that this cos of 90 minus theta is actually equal to sine of theta, or sine of theta is actually cos of 90 minus theta. Similarly, cos of theta is equal to AB by AC, but here sine of 90 minus theta is equal to AB by AC. So, we can say that sine of 90 minus theta is equal to actually cos of theta. So, we get trigonometric ratio in the form of complementary angles as the first one is sine of 90 minus theta, that is equal to cos of theta. The second one is cos of 90 minus theta, that is equal to sine of theta. The third one is tan of 90 minus theta, that is equal to cot of theta. Similarly, cot of 90 minus theta equal to tan of theta. It is cosec of 90 minus theta, that is equal to sec of theta, and finally sec of 90 degree minus theta equal to cosec of theta. These relations are true for all values of theta between 0 and 90 degree. From this we can also summarize that cos of an angle is equal to sine of its complementary angle. Similarly, sine of an angle is equal to cos of its complementary angle. Same follows for tan and cot, and similarly for cosec and sec. From this we can also observe that sine and cos show complementary behavior. Similarly, tan and cot show complementary behavior, and similarly cosec and sec, they also show complementary behavior.